All right, friends. I'm hoping that you made the connection and that you saw that every rectangle that we have, actually every parallelogram that we have, can be split into two identical triangles. So just like we did with the parallelograms, I want you to see where this formula is coming from that we use to find area of a triangle. And then we're going to have some time to practice applying it. Okay, just a lot of these things are similar. Just like with the parallelograms, we've got to make sure we know what we mean when we say base and what we mean when we say height. And it's really easy if your triangle is like oriented like this one, right? Like there's a base that's on the bottom and there's a height one that's going up. But that height you're always looking for, same as with the parallelograms, you're going to have a 90-degree angle there. That's telling you that this line is the height. The base is whatever side is perpendicular to that height line. So in this example, it's situated that way. Here you can see the perpendicular lines. But when I look over at this example, here's my height line, and I can tell because there's my 90-degree angle. But this right here is the line that is perpendicular to my height. So it's just like it took the triangle and it shifted it around. So you're always thinking about the base is perpendicular to the height. Those two perpendicular lines are going to give you the base and the height. Remember, guys, perpendicular forms that perfect 90-degree angle, which we see here. It's the same thing I was talking about with the parallelograms, that if I stood up there, dropped the rock straight down, I'm going to make a perpendicular line. Now, that's easier to envision in this case than it is over here, because I'd have to first turn my triangle. But if you look for those perpendicular lines, you're going to be good to go every time. Okay, here is another example where here's my base. Now they did not draw in that height line for me this time, but I can find it because I'm looking for a perpendicular line that goes all the way to the top. I guess I should be clear about that because I could also draw a perpendicular line here, but that doesn't tell me where, it doesn't get me all the way to the top of my triangle. So this would, whoops, wrong button. This would be my height. I could even draw that in. And even though they didn't label for me, you guys, we're on graph paper here. So you could figure that out. My base is 1, 2, 3, 4, 5, 6, 7, 8. My base equals 8 and my height equals 3. Okay, on the next one, I'm going to ask you to identify which one's base and which one's height, because just like in some of our other problems, sometimes we've got extra things. Sometimes triangles are situated like this, and there is already a right angle. So two of your sides are going to be your base and your height. Sometimes they're more like this, where one of my sides is the base, but neither of these sides are the height, right? Those are both like angled. That's like a rock, like slowly rolling down, not the straight down rock. So we've got to be paying attention to which one's base, which one's height. And then we're going to come back to talk about the formula.